Hey there, my name is Alejandro. Welcome back for day 334 of me doing Daily LeetCode Challenge at 31 years worth of green contributions here on GitHub. So today's strong is for June 15, 2025. Without further ado, let's get straight into it. Okay, today we got LeetCode medium problem 1432, max difference you can get from changing an integer. I see the word max. This is a maximization problem, which is a type of optimization problem, which means we're probably going to need dynamic programming, greedy, or divide and conquer. Okay, max difference you can get from changing an integer. Interesting, so it might be similar to yesterday's problem. If you're given an integer num, you apply the following steps to num 2 separate times. Pick a digit 0 to 9, okay, pick another digit 0 to 9. Note y can be equal to x. Replace all occurrences of x in the decimal representation of num by y. Let a and b be two results from applying the operation to num independently. Return the max difference between a and b. Note that either a nor b may have leading zeros. It must not be 0. Okay. Okay. This just seems like yesterday's problem. Am I done? Okay, they must not be 0, so if it's all the same. If it's all the same number. Okay, str_num is equal to string num. Same equals to length of set of str_num equals 1. If all digits same, return int of 9 times length of str_num we'll do 8, i.e. 9 minus 1 equals 8, 8. Right? A bunch of 9s. A bunch of 1s, since number cannot be 0. Not all digits are the same, so no need to worry about that edge case. Now, there we go. Okay, so now we don't have to worry about all the digits being the same. So, step 1. To get largest difference between A and B. Right, let's look at an example. 555, output 888. Why? Well, yeah, these are all the same, so, okay. And y equals 9 to store a new integer A. Yeah, the maximum difference. Yeah, so this is exactly yesterday's problem. Let me increase my brightness. I need to make A as large as possible and B as small as possible. Alright, step 1. Find A, the largest possible number. We do so by finding first non-9 digit, converting those into 9s. For digit and str_num, well, if they were all 9s, we would have hit here, right? So we'll say digit to replace is equal to next of digit for digit and str_num if digit doesn't equal 9. A is equal to int of string.join digit if digit doesn't equal digit to replace, else 9 for digit in sternum. Alright. Step 2, find B, namely step 2, B small as possible. First 9 digit, convert those into zeros. Actually, it'll just be the first digit. Turn on the next 0. The number will be, yeah, at least 1. Good. And then just return A minus B, right? Something like this. Yep, that's accepted. Let's submit. No. Okay, we got a wrong answer. Why is this wrong? Let's grab my terminal here, and whoops, okay, I've been doing a lot of brew stuff. Yeah, this is YouTube clone is, so I'm doing the LeetCode 150 full stack development course that's paid. I actually made a video about it today, but I have it as private on YouTube just because I don't think I'm allowed to share any course content, so oh well. But yeah, that's why I'm in here, but we can just do cd this. Yeah, 1 2 3 4 5 6, then I could just do 9 2 3 4 5 6 minus 0 2 3 4 5 6. Well, we'll grab that and we'll go into Python 3. Sure. 90,000 expected 82 grade. Why? Oh, 2 separate times. Ooh, okay. I can do it 2 separate times. Okay. That's the point. Oh, I will apply it twice. Wait, but that should make it... Okay. What? Wait. No, I have it right. Yeah, x into 9 and store it in A. 5 into 1 and store it in B. What am I missing? Why is it 82,000? I don't understand. Oh, they may not have leading zeros. Ooh. By taking... Okay, since we cannot have leading zeros, we must find first digit that is not equal to actual first digit. That digit is band. Band digit is equal to sternum of 0. doesn't equal bad digit. There we go. Yeah, there we go. Now we're accepted. I misread that part. Okay, now we have something else that's wrong. And let's see. 9288 output 900, where should be 8700. Here I'm claiming it should have been 9988 minus 1288. Right. Print f string A equals, print f string B equals. So A should have been 9988, B should have been 1288, 9988, okay. Whoa. Ooh. That's candidate 1. Oh no, so we just make the first one. Okay. I have 2 possible cases. 1. Change that one. 2. Digit is 1. Digit is 0. There we go. Doesn't equal 1. Is equal to none. We really don't need this, but it just makes me feel safer. I'll say B because it's runtime stuff with Python, whatever. I've never actually liked that. To replace will be equal to start none of 0, and we'll replace that with a 1. Else digit to replace is equal to next doesn't equal 1. And here we'll replace those with zeros. And then get rid of these 2. And then they should work. No, not quite. What did I do wrong? Oh, I stopped setting this. Yeah, there we go. Submit. Wrong answer still. What am I getting wrong this time? Okay. Num is this, so yeah, I should make 999, that's fine. Then this. Oh, first non-zero, first non-1. Right, because making 0 into 0 is not 1. digit doesn't equal 0. What if it doesn't have any 0? Yeah. Okay. B is equal to none by default. We'll just have an else. B is equal to none, just to verify. Actually, we'll just do this. And that way it's fine. Anything, anyways. That way we don't have to worry about that. Okay, something like this. Nice. Nice. And there we go, bada bing bada boom, 0 MS beats 100% of submissions. We'll just refresh here because it doesn't give me my little completed streak thing. But there we go, bada bing bada boom, we have it. Nope, not editorial, I want my submission, please. There we have it, and now it's 4 MS, of course. Of course, when we resubmit, then it's no longer that beautiful 0 MS crispiness. Although, there it is, there we go. Okay. Sweet. Was it just a little bit of a do to get that working? Just a few edge cases, but yeah, we got it working. Nice and tight at the end of the day, which is absolutely what matters. Oh yeah. Oh yeah, that's good. Okay, sweet. So nevertheless, as always on my videos, there are quick recap if I solve a problem. So this one is very, very similar to yesterday's problem. It took me a little bit of a while just because it's just like a few nasty little edge cases, but nothing that you can't get through. So basically, very similar to yesterday, you're given an integer num, and you can basically apply this operation to num. You can pick any digit from 0 to 9, call it x, pick any other digit from 0 to 9, call it y, and you can replace every occurrence of x inside of num as a digit with y, right? So you can replace like all the 4s with 7s, right? You can do whatever you like. So you're going to apply this operation once and call that number a, that new number, and you're going to apply it again and call that new number b, right? And then what you want to do is take the difference between a and b. Now what you want to find is what is the maximum difference between a and b, right? So for any a and b you can create, do a minus b, maximize this value, right? So, which means you're going to want to make a as large as possible and b as small as possible, right? So this problem really becomes what is the largest number you can make, what is the smallest number you can make, and then subtract those two values. So that way you will get the maximum a minus b difference you can possibly get. And now they give you a few restrictions, which is that this time, which is one of the edge cases that got me, is that A nor B cannot have leading zeros instead of they can have leading zeros, and another one is that they must not be 0. So let's think about the case when you would make a number 0. You would make a number 0 if all the digits are the same, right? And then you wanted to change the digit to 0. In that case, you can't do it, right? In terms of the minimizing. So that was the very first thing that I realized. That must be different from yesterday. So what I have is at the very beginning, I have a little a base case. So first I get I turn num into a string, just so I can go through the digits very easily. And I'll say, okay, are all the digits the same? I do this very lazily. I convert my string num into a hash set, so that way I get a hash set of all the characters. So I'll get all the unique characters. And if the length of this hash set is 1, that means there's only one unique character inside of the string, which means every single character is the same digit, right? So if all the digits are the same, then I know what I must do. The biggest number I can create is 9999. Remember, all the digits are the same. So if I change one to another, I can change all the digits, right? If I have 4, 4, 4, 4, 4, 4, 4, I can just say, hey, I want to change 4 to 9, and then that way I'll have 99999. So the biggest number I can make is 9999999, and the smallest number I can make is 1111111. Why? Because I cannot make it 0, 0, 0, 0, 0, 0, because the value must not be 0. So the smallest I can make the number is 1111111, and there we go. And then so that case, I know that, like, if I subtract a bunch of 9s minus a bunch of 1s that are the same length, it'll just be a bunch of 8s, right? So just return int of 8 times length of string num and convert that into an int, right? So just like a bunch of 8s depending on the length of the number, right? And I just get rid of this edge case so that I never have to worry about making a number 0, right? Because now there's like at least 2 different unique digits inside of the string of a representation of num, so I know if I change one to another, I won't actually make the number 0. So I just wanted to get rid of this annoyance very, very early on in the problem, so that's why I have this little base case over here for if all the digits are the same. Now, we can just be like, okay, we want to find the largest possible number, call it A, and the smallest possible number, call it B, so that at the very end, we can just return A minus B. So step 1 is find the largest number A, right? Well, this is going to be very obvious. Basically, if we have a number like 123, we want to turn that into 923, right? We want to make the most significant digit as large as possible, right? So if we had something like 1, 2, 3, 4, 5, 6, right? Or just, let's say we had 1, 2, 3, 1, 2, 3, and we want to change 1s into 9s, right? Because that would give us 923, 923, right? We made this as large as possible. Versus if we did, and this is even if I had something like 321, 321, I still want to turn this into 9 here and 9 here, because that's still bigger than changing the 1s into 9s, right? I have a number that starts with 3 here instead of a number that starts with 9, right? So I want to grab the very first 9 character, or digit I should say, and make all of those 9s, right? So that's exactly what I do. Since I know that all the digits are now no longer the same because there's at least 2 different digits, I don't have to worry about the case of everything already being a 9. So I can just say, okay, digit to replace will be the very first digit inside of str_num that is not equal to 9, right? So for each digit so loop through for digit in str_num, loop through all the digits, and only consider them if the digit is not equal to 9, and get me the next one, right? So it's just very easy. Like this will create a generator expression that'll just keep yield returning, and so when I do next, it'll just keep looping until I find the very first 9, give it back, and essentially go there. So it's kind of efficient. But it's just fancy speak. I'm just getting the very first non-9 character, right? And that'll be my digit to replace, right? But obviously, I don't want to replace 9s because replacing 9s with 9s is useless. So it doesn't change my number when I want to make my number as big as possible. So I grab the digit to replace the very first non-9 character, and I'm going to say, okay, my A value is going to be all the same digits except the digit I want to replace. I'll turn them all into 9s, right? So I'm going to do string.join each digit for digit in str_num. If the digit doesn't equal the digit to replace, otherwise if it is the digit to replace, I'm going to replace it with a 9, right? I'm going to string.join that, convert it to an integer, and that's my value of A. Now, step 2 will be find B, i.e. the smallest possible number. Now, this one's a little bit trickier because there's another condition that we cannot have any leading zeros. So since we cannot have any leading zeros, what this means is that we can't just take the first digit and turn it into a 0, right? We just cannot do that, right? If we have, the number 5, 4, 6, 7, we can't just turn all 5s into 0s because now we have a number with a leading 0. So we cannot do that, right? However, in a case like this, we could still turn this 5 into a 1, and that's totally okay, right? That's better than grabbing any other number, like, right? Even if I turn all of these into 0s, right? 5400 da 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 is still larger than if I just change this to a 1, right? So those are going to be my two possible cases. First, if the first digit is not equal to 1, right, it's bigger than 1, it won't be 0, right, because we're given an actual integer that we convert to a string, so we know that we won't have a leading 0. So the only other digit is like, if the starting digit is not equal to a 1, we can just change it to a 1, right? So in an example like this, if we have a 5, we can just change it to a 1, and that's the smallest number we can get, right? Otherwise, if the first digit is 1, then we need to be a little bit more clever, right? If the first digit is 1, I can't change it to a smaller number like 0. I can't, because I cannot have leading zeros. So I need to do the next best thing and say, hey, I need to find the first non-1 digit afterwards that I can change it to zeros, right? For example, in this case, it would be this 4, right? But if there was another one, I could be like, okay, I can't edit this one, because if I edited this one, I would be also editing this one, right? So I need to find the first non-1 character, and in this case, which is 4, and then replace all instances of 4 with zeros, right? And which is different, because in the first one, we replaced, the first character, 5, and all instances of it, we replaced it with 1s. In this case, we replace the first non-1 character with 0. So the number we replace with is different, right? In the first case, we replace the values with 1. In the second case, we replace the value with zeros, right? So again, I'll just break down those two cases again. Case 1 is if the very first digit is not equal to a 1, good, we can just change it to a 1 alongside every occurrence of it, right? So we can change that one to a 1. So if sternum of 0 is not equal to a 1, then the digit to replace will be the very first digit, and we'll replace all instances of that with 1s, right? Otherwise, if the first digit is a 1, we need to find the next best thing. We need to find the first non-1 digit to replace, and then replace all those with zeros now, right? So digit to replace, by default I put zeros, that way when I replace zeros with zeros, it does nothing. This is just for the case where, like, if the number is just 1s and zeros, I don't actually want to change anything, right? If I have a number like 1 0 0 1 0 0 0 0 1 1 1, like some binary number that starts with 1, I can't actually make the number any smaller, right? Because I cannot change the 1 to zeros, otherwise I have leading zeros, and then anything else. So I can't change 1s, and then zeros, changing them to zeros does nothing, so I don't actually do anything, right? So that's why I just set up digit to replace equal to 0. Really, I could just say, like, okay, if there's no zeros and 1s, just keep b equal to num. But this was just me being lazy. I'm like, okay, replace zeros with zeros as the base case. There you go. It doesn't do anything, right? But otherwise, for each digit in sternum, if the integer version of the digit is greater than 1, i.e. if it's not equal to 0 or not equal to 1, then that's the one we want to replace stuff with, right? So digit to replace will be equal to digit, and then we do the same break, and then we do the same thing, right? String.join digit, if digit doesn't equal digit to replace, otherwise replace it with a 0 for each digit in sternum and put that into my b, right? Or by default, if there was only 1s and zeros, it'll just be 0. And then there we go. Now we have the biggest number, and we have the smallest number we could get, respectively a and b. So then we just return their difference, a minus b, which will be the maximum difference. And there we go, bada bing, bada boom. We have a nice and efficient 0 mess speeds 100% solution to this problem. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, and able to perform, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So till then, ciao, ciao, my friend. Bye-bye.